The main source of energy is sun. So instead of depending on fossil fuels, we can mainly depend upon solar energy. So the renewable energies we have solar energy, wind energy, right, tidal energy, right. So out of all those renewable sources of energy, solar energy we are human as depending. So today in our discussion we're going to discuss on what is solar energy, how to convert solar energy into usable form, what are the applications of solar energy, and construction and working of the devices which is used to convert solar energy into usable form. Okay, so there are some device which is used to convert solar energy into usable form. So what is the name of the device? So what are the applications of that? Okay, and construction and working of that, advantages and disadvantages, applications. We will discuss today in our discussion. I think everyone might have got what is the idea, what is the topic we're going to discuss today. Right. So these are panels, photovoltaic cells or solar cells. Solar cell or a photovoltaic cell is a device which convert sun energy or solar energy into electrical energy or usable form. PV cells or solar cells or so-called photovoltaic cells are devices which convert solar energy into electrical energy. So in this one box, this entire thing, blue color thing is called as an array. The small cells are called as photovoltaic cells. When photovoltaic cells are connected either in series or parallel, it forms a module. When modules are connected together, two or more modules are connected each other, it forms a panel. One single plate is called as a panel. In traffic signals, you might have seen, right? One blue color thing, that is a panel. When panel is connected either in series or parallel, it forms an array. So array is used for mass energy production. So almost rooftops, if you use this, what will happen? Energy, whatever is required for a household purpose, can be generated. So in such cases, arrays can be used. For table lamp, for mobile charge, their panel can be used. Okay, so let us see what are the applications of photovoltaic cells. So the applications of photovoltaic cells are called as important of photovoltaic cells or solar cells. So these photovoltaic cells or PV cells are renewable source of energy. So until the sunlight is shining on the PV cells, energy can be obtained. Once PV cells light stops shining on the PV cells, you cannot obtain any more energy. The energy obtained in PV cells are eco-friendly. So there are no reactions. There are no redox reactions. So how it works we'll discuss later. There are no reactions, there are no byproducts, nothing. Only energy is liberated. Sun falls on the PV cells, energy will be taken continuously. There are no byproducts. There is no problem of wear and tear. There are no moving parts in your solar cell. Okay. So if you're using it in a roof integrated system, so you can mainly you can prevent your home from overheating in summer, and whatever energy is obtained, it can be used for your whole household purpose also, and you can stop depending upon the electricity power supply board of your particular state or city. So what are the other main applications of this? So it mainly used in traffic signals, it is used in railway signals, and it is also used in calculators, watches. Other major application, can you tell? So other major application, so where, so satellites and spacecrafts also need energy, isn't it? So we cannot supply electricity, but we cannot give a line from here to there, right? So we cannot supply fuel, that is diesel, kerosene also, or we cannot supply batteries. And how? Solar energy, 24 bar 7, 365 days sun will shine on the panel. So 24 bar 7 energy is required there for the satellite to work. How? So there your solar energy, solar cells or solar panels plays a major role. So next, it is used in domestic appliances. It's used in solar solar machines, solar for transport purpose, etc. So and remote places, especially in forest areas, the PV cells are the major. These are the major source of energy. So these we have seen what are PV cells definition. and we have seen what are the importance or uses of your applications of your PV cells. Let us see the construction and working of your PV cells also. So PV cell is mainly it's made up of a silicon. So it is called as a silicon diode also. It acts as a silicon diode. It is not called silicon diode. It acts as a semiconductor diode. It is mainly made up of silicon. When we take the cross section of your photovoltaic cell, it appears like this. One of the electrical contact is made up of metallic grid. Other electrical contact is metallic layer. So when sunlight falls on your photovoltaic cell, this is your photovoltaic cell or PV cell, when sunlight falls on this, what should happen? Either it should reflect, it should absorb, or it should refract. So when sunlight is reflected, it goes waste. It should be completely absorbed and should be converted into electrical energy. Right? Only then it will be used. If it is reflected, what is the use? If it is refracted, what is the use? It should not reflect, it should not refract. So whatever light is incident on the solar panel, it should be absorbed. It should not be reflected. So in order to prevent the reflection of sunlight, we're going to coat the anti-reflective layer in between the grid lines. So usually used anti-reflective layer is silver nitride. Okay. So when sunlight falls on the PN junction, what happens? Electron hole pairs are generated. What happens if this is the PN junction you have? So this is the PN junction. So electrons, sunrise falls here. Here electron hole pairs will be generated. So electrons will move towards the p-type. Holes will move towards the n-type. Electrons will move towards the p-type. Electrons is p-type is electron rich, n-type is hole rich. That is, it will become positively charged. P-type is negatively charged. When we connect both the ends to some external device, we can see the flow of electric current, and that is called as photovoltaic current. So there is a small animated video regarding how the photovoltaic cell works, solar energy is obtained. Let us see.
The most commonly used renewable energy source is solar energy. But how is solar energy used to generate electricity? A photovoltaic or PV system is used to convert the solar or light energy into electrical energy. The basic component of the PV system is known as the solar cell. A single solar cell has the capacity of producing about 0.5 volts of electricity. A solar panel or solar module is the combination of several solar cells connected in series to generate usable voltage. The solar panel voltage can be increased by increasing the number of solar cells. For example, 30 solar cells connected in series will produce an output of 15 volts. A combination of solar panels connected together is known as solar array and can be used to achieve required current and voltage. How does the solar cell work? The generation of electricity on exposure to sunlight is known as the photovoltaic effect. This principle is used by solar cells to produce electricity. The solar cells are made up of semiconductors, mainly silicon, and comprises 3 layers. The top layer, called the N-type layer, is comparatively thin and contains high concentration of electrons. The bottom layer, called the P-type layer, contains high concentration of holes. When the P-type and the N-type semiconductor is joined, it forms a PN junction. On forming a PN junction, the electrons of the N-type material try to reach the P region, creating a negatively charged layer. Similarly, the holes of the P-type material try to reach the N region, creating a positively charged layer. This region between the two layers is known as the depletion region of the semiconductor. Sunlight penetrates the top thin layer easily to reach the depletion region. Due to the deficiency of charge in the depletion region, it contains neutral atoms. These neutral atoms are broken when the photons from the sunlight strike the depletion layer. This knocks the electrons from the neutral atoms, leaving behind the holes and producing free charge carriers. Then, the electrons move towards the n-type layer and the holes move towards the p-type layer due to the electric field present in the depletion region. On connecting an electronic circuit, the electrons flow through it, generating electricity to electrical devices like bulb, fan, etc. Please subscribe our.
So what are the advantages? So advantages is, so we can get energy until sun is present, right? So the gases are, no gases, it is eco-friendly. So, but what are the disadvantages? So it is high installation cost. So only during the installation you are supposed to invest more. Other major disadvantage is during cloudy days. So during winter season, the expected output cannot be obtained. This is the another major disadvantage of the solar panels. So sunlight is produced during daytime, so but we can save the energy for night time. That is, as I told, diffuse source. When sunlight is diffused, that is during winter season, we cannot. And other major disadvantages, it is geographically it is not suitable for all regions. So in Kashmir, you cannot use. Only in 2 months during summer you can use. During winter season where is snowfall you cannot use. In UT you cannot use. Right. So region wise we are supposed to use C and use. So these are the major disadvantages of the solar panels. Thank you. In the next discussion we'll see the synthesis of solar cells. Thank you.